Hello folks, let's look at a scenario here. Let's say you've got a machine shop. Here's a machine. Okay, there's a machine, that's a manual machine. And you've got a guy running it. There's a person, it's kind of a bird's eye view looking down, so he looks like a circle. So there you've got one man, one machine. And he's running that thing, making parts for you. I like to use easy numbers for mathematical reasons, makes the illustration easier to work with. So I'm going to say, let's say this guy is making 20 bucks an hour. Okay, so he's cranking out parts, 20 bucks an hour. And you're used to paying that wage and everything is grand. But wouldn't it be nice if you could pay that guy 10 bucks an hour? How would you do that? You put in another machine. Now you got one man, two machines. But he can't be in two places at once because, that's against the laws of physics so far as we know. So you've got one man, two machines. So this machine, you decide, those are all the buttons and knobs, to buy a CNC machine. Now that is very doable. Yes, it is a more expensive machine, but once this thing is set up, once it's programmed and set up, it's off and running. And all he's got to do is run over here, put in a new part, take the old one out, put in a new part, and go back to doing this, depending on what we call the cycle time of the job, how long it takes to run a part. He's got time over here to devote to something else. So now all of a sudden his wages have become, well, you could say, my pen's not working here. I'm like maybe $10 an hour. He's running two machines for the same wage. Okay, well that's pretty good. But there's another way to look at it still. Let's say Fred here, let's call him Fred. Fred comes over here, he programs it, he sets it up, gets it going, proves it out, makes sure everything is good, and then he has Charlie come over and run the machine. Now Charlie's making 10 bucks an hour, let's say. And so Fred here is working for 20 bucks an hour, but he's only on this machine part-time just to get it set up and running, make sure it's doing things well. And you've got Charlie over here running that machine for 10 bucks an hour. Not bad. That is actually a pretty good deal, and that makes this machine here even more profitable. Now suppose that while this machine is running, Mr. Charlie here is twiddling his thumbs. So what do? Haha, you're a smart guy. You put in another machine, another CNC. So now you've taken his wages and cut them in half also. Now he's essentially working for 5 bucks an hour, running the two machines there, getting twice as much work done in the same amount of time, with only a little bit of time taken from Fred over here to devote to programming and setup. You see where this goes. This is a matter of efficiency. Buying the good equipment is a way to get there, to make your business more efficient, to increase your profits and make better product along the way. Now, there is more to this, of course, because let's say, you want a super deal on these machines, so you buy used equipment. Okay, so you buy used equipment, and these machines here are running, and for a while they might do really good, but there's always a problem with used equipment, and that is that you don't know its history. You don't know what it's been through. If it's a mill, chances are that the spindle has been driven into the table. You want to look for that if you buy a used machine, see if there's damage to the table. If it's a lathe, I can almost guarantee you that someone has taken the chuck, or tool in the chuck, in the turret, what holds the tools, and smashed it into the chuck. That usually happens within the first few months of a new machine being on the shop floor. Now all of a sudden that machine is compromised in several different ways. And that's what you get for a used machine. You don't know its history. With new equipment, you know its history. It's brand new. It's the quality of the manufacturer. You buy from a reputable manufacturer, you've got a good machine. Buy from someone that's real cheap and low quality, you're going to pay for it in the long run. And by long run, I don't mean down the road. I mean you're going to pay for it with downtime because this broke, or this isn't quite working right. It does it sometimes, but not all the times. Or it can handle this much of a cut, but not this kind of cut. That's what I mean by down the road a bit. You're going to find out the shortcomings in a lower quality, cheaper priced machine. Okay, but there's more to it than that. And here's where I want to go with this. in this particular scenario, you've got a manual machine here. And what goes into a manual machine? How many, shall we say, systems are there that can possibly cause you trouble, as in maintenance and repairs and downtime, which is really what we're concerned about. It's downtime. We don't like downtime. Well, in a manual lathe, you've got mechanical systems. You've got gears and pulleys and shafts and belts, all these kinds of things that drive the machine, that make it do what it's got to do. But there's one other system, and that is your electrical system. It needs power. So you've got two systems there. If you're going to have a mechanic fix your machine, your maintenance department, they need to be skilled at mechanical things and electrical things. You know, fuses and switches and relays and you know, whatever else goes into these manual machines. Not a whole lot there. But here's the deal. This is where it gets tricky. Because when you go to a CNC machine, now you've got a lot more going on. You've got the mechanical, gears and things like that can still go wrong, and they're in these machines too. You've definitely got an electrical system. There's a lot of electricity going through that thing, and it's got to be just right also. You know, fuses and, like I said, relays and limit switches and all these sorts of things. But you've got more than just that. Typically, you've got a hydraulic system. So you've got to watch for that. You can spring a leak. You put the wrong oil in there or something like that. That'd be very bad. You've got a hydraulic system that can cause you all sorts of problems. On some machines, I spelled that wrong. You've also got a pneumatic system, air. Now on some machines it'll be one or the other. A lot of machines use both, because hydraulic is really good for some things where you need a lot of force, and it's got to be strong and fast, you know, really clamp things down or move things with a lot of force behind it. Other times you like pneumatic because it isn't as messy. You've already got compressed air in the shop. It doesn't make as much noise, and a lot of times it's faster. It just goes click click, and it shifts your part over, or click click, and it clamps unclamps, or click click, and it does you know, opens a door or moves a tool changer or what have you. So you've got pneumatic systems. Okay, and then of course, like we all know, CNC has a computer on board. So you've got the computer system. Now that there is actually a bit more than just one item here. Here you've got, of course, the hardware. You've got the hardware, the mechanical circuit boards, you know, and the circuitry and all that kind of stuff, which is kind of part of the electrical system. In a way, it's separate, but related to it. But you've got the hardware, and then you also have the software. So you're looking at somewhere between 1, 2, 3, 4, 5, maybe 6 different systems that can go wrong in a CNC machine. You want to buy yourself a CNC machine. Remember that Y curve or that Y graph that I had in that previous little presentation? Well, that really comes into play when you're talking about CNC, because there's so much that can go wrong with them. And generally it does. People are careless. People don't keep up on the maintenance on them, things like that. They do a bad job of programming. They don't know quite what they're doing, or they're just not cautious enough. And actually, to that point, I want to go off in that direction for just a minute. The folks that create these CNC machines over the decades here now, the engineers, the scientists, the managers and metallurgists, you know, all the people that have put their time and energy and their talent into these things have really done a good job of making good machines. Not that all of them are good, but they put in so many features that make these machines so safe. It is just incredible. Optional stop, single block, dry run, feed rate, RPM overrides, things that really allow the operator, if he knows what he's doing, to control that machine and walk it in. Theoretically, there should never be a crash on a CNC machine, theoretically, because they put that much stuff, that much thought, and that many features into these machines to make them almost crash proof. Now, people being people, we'll find a way to crash just about anything. And, you know, we're all forgetful. We all have lapses of memory and lapses of attention, what have you. That's part of life. And we know that. And so that's part of the game going into this stuff. But they've really done a good job of making these machines as bulletproof as they can. But when you buy used equipment, the risks go up significantly because you don't know what that machine's history has been, and there are so many different things here that can go wrong that you really do have to be careful. There's a saying out there that Murphy's Law: if there's anything that can go wrong, it will go wrong. And yeah, a lot of times that is true, but you got to be careful with that one, because a lot of times, and I find this to be more true and happen more often than not, that we actually give Murphy the ability to make things screw up. We choose not to pay attention to the warning signs, to the maintenance, to the precautionary measures that we've been given. The little voice in the back of our mind telling you, hey, do a sanity check on that. Back up a minute and walk this through one more time. When bad things happen, yeah, if it can go wrong, it will go wrong. Murphy's Law. But we actually enabled Murphy to make it so miserable for us. So that's something to think about too. Anyhow, I think that's about it. I just wanted to paint that scenario of one man, one machine versus one man on two machines versus one man running multiple machines and using good machines instead of used machines. In some shops, I'll just warn you, they a bit overplay this to where they'll have one poor guy running 4 machines, 6 machines. And I'll tell you, I've been there, and it is hard. It keeps you running around and trying to pay attention to all these different machines with their little subtleties, and which one you did the offsets on, and which one you did this on, and how old the tools are getting on this one here versus that one over there. It's a lot to keep on your mind, and a lot of people think all you got to do is put the part in, push the button, and out come finished parts. Yeah, that's true, so long as you can keep on top of the game. And that gets really hard to do. It's very taxing. So we are only human. You've got to give people a break once in a while. Alrighty, well, that's it for this episode. Thank you very much for paying attention. Good luck and God bless you.